In this video, I want to briefly cover data structures because that's something you'll commonly hear in your CS class or read in whatever they kind of crap they tell you to read. And it does, at least in my school, it didn't really explain it all that well. But for example, this is a data structure. This is a data structure. This is a data structure. You know, these are all data structures. Now, you can think of a data structure as a collection of types, so to speak. So I figured the best way to kind of show you these would be to show you them in use in a real world example. So for example, I have this struct here, this data structure called vColor, and all it is 4 floats, a value for red, green, blue, and alpha. So it's just a data structure that consists of 4 floats. So whenever I want to, I'll go ahead and construct a data structure of that type. So I'll create a vColor containing 1 for red, 0 for green, 0 for blue, and 1 for the alpha. So whenever I want to make use of it, I can easily go to my draw line. So you can see here's my data structure right here of color. I'll just simply read from that data structure to make use of it. So here I'm changing the color of my line. So for the color, I want it to mimic the color of the data structure color that I created. So color red is for red, color green for green, color blue for blue, and color alpha for alpha. It's that simple. Like that, just this right here, you can even ignore the constructor. That is a data structure. Same thing goes with vectors. So in like Unreal Engine, for example, you'll use f-vector, f-rotator. Well, even though it's called f-rotator, it's still like, and same thing with the f-vector. All it is a structure that contains 3 floats. So like this, for example, is kind of the same thing as an f-vector. They just have a lot more functionality built into that data structure so that you can do a bunch of things with it. So for example, I have this vector here. It's a 3 vector, so it consists of the x, y, and z. So these would be like your world coordinates on the map. So let's say you have a friend who's on the floor, and then you have someone else who's on the floor directly above you. Well, their z value vertically would just be higher than yours. So these are kind of like your world areas. So inside of your data structures, you can overload or overload, replace, I don't know what the actual terminology is for it, but you can change operators. So like the subtraction, for example. Well, I need a way to get the distance between vectors. And the easiest way to do that is, I don't actually need this. I don't know why that was still there. The easiest way to do that is to simply subtract the vector. Well, for this vec2, which I have not overloaded, I'll go ahead and try to do that. So just anywhere right here, I'll do vec2, first vec, and yeah, I'll do vec2, second vec, and let's do float distance. So distance equals whatever, first vec minus second vec. Well, I can't do that. No operator matches these to rams. So there's no way to tell the computer, how can I subtract with this data structure? So that's where you can, create your own operators. Well, I guess replace operate, I don't know what you'd really call this, but you would create your own operators. So if I were to change this up a bit, and I actually make use of this because this is how I get the distance. I got it right here. So local player location. Location is a vec3. So it is this vector right here, or this structure, this data structure right here. Because I overloaded the subtraction, so we can now subtract a vec3 from a vec3, which allows us to do just simply this. So that way you can kind of build your own functionality to it. And same things, like you should be familiar with structs if you're watching this, but you can add custom or functions and stuff like that to do these, like member functions, to do the same exact thing. So you would just, in this vec3, you would just create your own float get distance const vec3. Let's do, destination. Keep the names the same. Return whatever. So you could do it that way, or you can simply do like what I did here, overload the subtraction, and be able to make use of it. Now, data structures, pretty much they consist of just data types. So for example, a data type, that's a float. So we could do that, or we have others here. I think, like entity data, for example. Well, entity data contains this data type, this data type, data type, data type, data type, and then our data structure, so our vec3. And then it goes back to another data type. Well, you can have kind of like nested data structures, so to speak. That's not necessarily a very good way to put it, but you can put your data structures inside of other data structures just like you would a data type, like a Boolean, integer, float, string, whatever. You can use them in the same format. And that's kind of what I'm doing here. So I have local player. Local player is of type entity data, just like entity is of the type entity data. This is the data structure. This data structure contains my other data structure, which is vec3. So it's the x, y, and z vector. This guy right here. What we do is we use our entity. We can get access to our vec3 data structure, which is called location. And then if I wanted to, we could access other portions of it. So for example, local player location, which is our vec3, dot x, y, and z. So you access them just like you would anything else. And you can make use of them however you wish. And I think that's pretty much everything. I think that sums up data structures pretty well. But they're just, you can kind of think of them not as your own data types, but just as kind of a collection or a use, or just a container to hold information that you want to keep. So like I'll commonly use things that it can be reused. So I have, if I need to, I'll split data types into two separate things and go about it that way. So hopefully that gave you a rough understanding of data types and their uses, because they are very useful. So you can kind of think of it, anytime you're using struct, most likely it's going to be a data type. So at least in C++, now that we have classes, because classes and structs, they're pretty much the exact same thing. Just by default, a struct is public, and by default, a class is private. That's it. So you'll commonly use classes for what you like, kind of like your normal objects, like a person, a character, whatever. And you'll use structs to consist and hold data, like we are using here. So like I could have a class called entity. That entity class, I could have specific data, something that's related to like, its team health, that kind of stuff. And then another one that's related to like its bone matrix, its bone locations, all that kind of stuff. So you would have custom data structures for each thing that you can easily pass on to whatever. So anyways, I'm kind of rambling on at this point, and I hope that made sense. Go ahead and Control Z, whatever I end up doing. I still want to make sure you're removed. Hopefully that made sense. And if you have any questions or anything like that, you can feel free to join my Discord in the link below, and I'll try to answer any questions you have. If you want to help support me, you can find a link to my Patreon in the description, where I have a Patreon only series where we create Team Deathmatch inside of Unreal Engine, just completely from scratch in C++. And that's pretty much all for this video. So I will see you in the next one.